Do you know how line bisecting method works? I hope you know that, right? But why it's true? First 1 minute I will explain how to bisect a line. I will show you the proof of it. You know this method very well. Let's draw a straight line. So if you want to bisect this line, what you do? You will take in a protractor and measure the more than half of the distance. You will draw an arc, right? Let's draw an arc. So similarly, you will be drawing another arc at the downside here. And without changing any dimensions, you will take to the other point here and we'll just cut this arc at the bottom. Similarly, so you do at the top side. Okay. So now what you do, you will take a ruler and you try to join these 2 points, right? Now let's mark the points. This is the point A and this is the point B. So it exactly divides the AB line into the middle. Now AM equal to MB, right? So why it's happening? Okay, we bisected this point and this point. We did not bisect this point, right? When it joined it, it automatically became the midpoint of the AB, right? Why it's happening? Okay, let's see the explanation. Let us take AB or the 2 points in the coordinate system. The first point is A, x1, y1, and the next point is x2, y2. So the joining line is the AB. Now we are trying to bisecting this AB line. Let's take any point. Okay, let's take any point on the coordinate system P, x of y, having the equal distance between the A and P. We will see there are the many points like the xy here. I'm just taking any point, a random point. That's why the coordinates is not fixed. It's randomly taken xy. So the xy point having the equal distance from the point A and point B. So the condition for the equal distance point AP is equal to BP. So do you know what is the formula for the distance between the 2 points? Let's take the coordinate system. The first point is, let's take x1, y1 and another point x2, y2. If you want to find the distance between these 2 points, that's the AB here. So what is the meaning of the x1, y1? It has the x1 distance from the y-axis and y1 distance from the x-axis. Similarly, point B, x2, y2 means it has x2 distance from the y-axis and y2 distance from the x-axis. So we have drawn a parallel line to the x-axis here and a parallel line to the y-axis, and the mating point is point C here. So what is the distance BC here? The total distance y2 minus y1, right? So BC distance equal to y2 minus y1. Similarly here AC distance is the total distance x2 minus x1. So this is the right angle triangle. So we know the 2 sides. How do you find the hypotenuse? That's the distance between the 2 points AB. You know the Pythagoras theorem, right? So AB square is equal to AC square plus BC square, right? So what is the AC here? It is x2 minus x1 whole square plus y2 minus y1 whole square, right? So AB equal to square root of y1 whole square. So I erased all the markings. So the distance between the 2 points AB can be written like square root of. So let's take the P point having the equal distance from the point A and B. So the condition is AP must be equal to the BP. So if AP is equal to BP, AP square must be equal to BP square. I'm just putting the square to just cancel out the square root on the either side of the equation. Okay, how do you find the distance between the point A and P? It is simply x minus x1 whole square plus y minus y1 whole square equal to, similarly, it is x minus x2 whole square plus y minus y2 whole square. If you simplify this, it is x square plus x1 square, it's same as b whole square 1, right? Minus 2 x1 x plus y square plus y1 square minus 2 y1 y equal to x square plus x2 square minus 2x2 x plus y square minus, plus y2 square minus 2y2 y. If you notice here, both sides the x square term get cancelled and y square terms get cancelled. If you bring all the terms to the left side of the equation, okay, so and you take the common x here. So x is over here and also here, right? So if you take the x as the common here, the left side we have the minus 2x1 and the right side we have the minus 2x2. If you come this side, it will become plus 2x2, right? Similarly, if you take common y here, okay, plus y if you take common here, and what we have here, minus 2y1 we have, come this side, it became like plus 2y2, okay, plus what else we have here in the left side, we have the x1 square here, right, the constant. So it's x1 square, and if the x2 squares come to the left side of the equation, it became x2 square, right, equal to 0. If you observe this one, this is the equation something in the form of ax plus by plus c equal to 0. Here x1, x2, y1 by 2 are the constant. That is the known points from our right. The x1, y1, x2, it is the known points. Whichever you do not know is the x is the coordinates. If you see the relation between the x and y here, it has the very linear relationship. What is the meaning of the linear relationship? If you just know the 2 points, okay, if you join the 2 points, all the points will get having the same relationship because all the points along the line will satisfy the line equation, right? So we will find the 2 equal distance points, bottom one and top one, and we will join them. So all the points along the line will be having the equal distance between the point A and that point. That's the reason whichever they are intersecting this line, right? So that point also having the equal distance, like AM equal to MB. That's the reason all the points along the line having the equal distance from the point A and B here. That's why you're getting the midpoint of the line.